Theorem 11. If three parallel lines cut off equal segments on some transversal line, then they will cut off equal segments on any other transversal. Okay, the first thing is to look at what is a transversal. So I have the definition over here. A transversal is a line that cuts across two or more, usually parallel lines. Now this is the transversal T, and these are the parallel lines, or the lines L, M and N, and in this case they happen to be parallel. And in our theorem it states that if three parallel lines cut off equal segments on some transversal, then they're going to do the same on another transversal. So therefore we know by looking at this here that AB is equal to BC. Now on the diagram I also have another transversal line, and it's the line K, and it intersects the parallel lines at D, E and F. Now if our theorem is true that our transversal or parallel lines cut off equal segments of our transversal and AB is equal to BC, what I want to prove is that DE is equal to EF, that they cut off equal segments of some other transversal. So with a theorem, the most important thing to proving a theorem is the diagram. If you can understand and draw the diagram, you can prove the theorem. So what are you given? The first thing in a theorem, you write down then what you were given. So you're given the three parallel lines, and they're L, M and N, and they're intersecting the transversal T at the points A, B and C. And from what we're told in the theorem, we know that AB is equal to BC. We're given another transversal K, and it intersects the parallel lines at D, E and F. And what we want to prove is we want to prove that the length DE is equal to the length EF. Now the next thing is a construction. So on our diagram we're going to construct a line that goes through the point E and is parallel to the transversal T. Okay, so to do that, just simply like that, we draw our line, and our line is going to intersect the line L at P and intersect the line N at Q. Okay, so moving on into our proof. Okay, so with a lot of theorem proofs, you use existing knowledge from other theorems to prove the theorem. So in this case, what I'm going to use, the first thing I'm going to use is I'm going to look at what we know about parallelograms. Okay, so I'm just going to point out that there are two parallelograms here. The parallelogram PEBA and another parallelogram EQCB. They're all parallelograms. Okay, now so what do I know about a parallelogram? Well, I know that opposite sides in a parallelogram are equal. Okay, so looking at these parallelograms, I can say that PE is equal to AB. So PE is equal to AB, and I can also say that EQ is equal to BC. And we always have to state the reason, because they're opposite sides of parallelogram. Opposite sides of a parallelogram. Now, I already know, as stated in the theorem, that AB is equal to BC. So, but AB is equal to BC. Now I'm stating here that PE is equal to AB and EQ is equal to BC. Now if I know that AB is equal to BC, then I can say that PE is equal to EQ, because they're both equal to the same thing if AB is equal to BC. So that's our first step. Our second step then is we're going to use congruent triangles. So we're going to look at two different triangles. We're going to look at the triangle DEP, and we're going to look at the triangle FEQ. Okay, so in triangle DEP and triangle FEQ. So focusing in on those two triangles. Now, the first thing that I can state, because I'm after proving it in the last part of the theorem, is that PE is equal to EQ. So PE is equal to EQ, because it was just proven above using the parallelograms. Now, I can also say that the angle DEP and the angle FEQ, so our angle PED is equal to our angle FEQ, because they are opposite, vertically opposite angles. And that's the reason, vertically opposite angles. Okay, so I now have a length, which is PE. I have an angle, so I've the two lengths equal, I have the two angles equal. Okay, and now what I'm going to look at is, I'm looking for angle, side, angle. So if I could get that angle up here equal, and that I'm going to use alternate angles. So if I look here, I have two parallel lines, and my angle DPE and my angle FQE are also equal, because they're alternate angles. So taking my two angles, so DPE is also equal to the angle FQE, because they are alternate angles. Why did I pick out alternate? Because alternate angles are always formed by parallel lines with another line, which we now know is a transversal intersecting. Okay, so therefore I can conclude that the triangle DEP is equal to the triangle FEQ because of angle, side, angle. So we have an angle, a side, and an angle, and we have an angle, a side, and an angle. Okay, so therefore I can just conclude that I wanted to find out my other side on my two triangles is DE, and because they're congruent triangles, I can now state that DE is equal to EF, because they are corresponding angles into congruent triangles, and that is the theorem proved.